Today you're going to be looking at 4C, identifying, calculating, and applying the slope of a linear function. The first thing we want to answer is, what is slope? Well, to us slope is rise over run. It's the steepness of the graph of our linear function, and it tells us whether the graph is increasing, decreasing, zero, or undefined. In the case you see below, to move from the leftmost point to the rightmost point, we go up 1, so our rise is 1, and to the right 3, so our run is 3. So our slope would be 1 over 3, and we'll talk about how we get there later on. But for right now, you just need to understand that it tells us the steepness of a line and whether that line is increasing, decreasing, zero, or undefined. When we look at slope, we tend to categorize them. We categorize them based on increasing, decreasing, zero, or undefined. And so a graph that goes up and to the right is increasing, and it has a positive slope. A graph that goes down and to the right is decreasing and has a negative slope. A graph that is horizontal has zero slope. It doesn't go up or down. And a graph that goes vertical is what we call undefined. It means we cannot calculate the slope. The other way we can categorize slopes is by their steepness. So the graph on the left is the flattest of these four graphs, so it's not very steep, and it would have a slope much closer to 0, so like 0.1. The second graph gets a little bit steeper, and it would have a slope a little bit bigger of 1. To the right, if you go move again, it gets even steeper yet, and it's going to have a bigger slope of 2. And all the way on the right, you can see that it's a pretty drastic line. It's pretty steep, and we say it would have a slope of 4, for example. So as it gets steeper, the slope gets further from 1. Now, when we talk about how we want to identify slope from a graph, we have two questions we ask ourselves. Is the slope positive, negative, zero, or undefined? And then what is the slope? So if we look at an example here, we see that in our first graph, our line is going up and to the right, meaning it is positive. It has a positive slope. And then to find our actual slope, we count how many do we have to move up and how many do we have to move to the right. So here we go from 5 up. 1, 2, 3, so it'd be up 3, and then we move right 1, 2, so it's up 3, right 2, and our slope is 3 over 2. Now, I'm going to give you a chance to go ahead and try these second two. Pause the video, and when you're ready to see the answers, hit play again. Here, if we look at these second two, we can see on the second one that it is going down and to the right. Therefore, our slope is negative. And remember, we always want to work left to right with our points. So we start with our leftmost point. We go down 1 and right 1, 2 to get to our second point. And we could do the same thing from our second to our third. So down 1, right 2. And that's how we get our slope of negative 1 over 2. Negative being because our slope is negative and is going down. Here on the far right, if we look at our graph, we can see it's going up and to the right. Therefore, it has a positive slope. And if we move from one point to the next, remember we start on the left and work our way right. We go up 1, 2, 3, 4, right 1, up 1, right up 4, right 1, so we have a slope of 4 over 1, or 4, because 4 divided by 1 is just 4. Notice that these other two, we couldn't reduce the fraction any further, so we left them alone, whereas on this third one, 4 divided by 1 can be divided evenly, and we get an answer of 4. The other thing we want to talk about is how do we identify slope in an equation. So the two equations where the slope is very directly given to us are slope-intercept form and point-slope form. Both of their names give us the hint that the slope is somewhere in there. Here we see that our slope is this number that is in the spot of m. Whatever is there is our slope. Same thing applies in point slope form, where the m right here represents our slope. So if we compare that to our two equations on the left here, the first one's in slope-intercept form, so y equals mx plus b. Our m value is 3 over 2, so our slope is 3 over 2, which would tell us that this graph would move up 3 and right 2. If you look at the second equation here, which is in point slope form, we see that in our m spot, because it's y minus y1 equals m times x minus x1. In this case, the number that is in the spot of m is 3, so our slope is 3, which tells us that we move up 3, and if it's ever just by itself, it always means we move right 1. So this would be moving up 3 and right 1. Go ahead and take a minute and try these next two. Pause the video as you do, and then when you're ready to see the answer, go ahead and hit play. If we look at these next two, on the first one we can see that our slope y equals mx plus b, and the m spot is negative 5, so our slope would be negative 5, which we say tells us to move down 5 because it's negative, and right 1 because there's no number listed below, so we automatically know it means right 1. Now, on the equation on the far right, y minus y1 equals m times x minus x1. The number that's in the place of m is 4/5, so our slope is 4 over 5, meaning that we would move up 4 and right 5. The last thing we want to talk about for slope is how to calculate it when we are given 2 points. When we are given 2 points, they are x1 and y1, x2 and y2. Our slope formula is y2 minus y1, so the second y value minus the first y value, divided by the second x value minus the first x value. If we apply that to our first situation, our second y value is 10 minus our first y value, which is 5, so 10 minus 5 gives us 5, and our second x value is 5 minus our first x value, which is 3. 5 minus 3 gives us 2, and we have a slope of 5 over 2. We cannot reduce that fraction any further, so we know we are as simplified as possible. That tells us that we move up 5 and right 2. Go ahead and pause the video as you try this with this second set of numbers. When you're ready to see the answer, go ahead and hit play. In this case, our second y value is 21 minus our first y value, which is 1, and our second x value is 6 minus our first x value, which is negative 4. Now, notice in this case we have two negatives on the bottom. That means we can rewrite this as 21 minus 1 over 6 plus 4 because two negatives make a positive. 21 minus 1 gives us 20. 6 plus 4 gives us 10. 20 divided by 10, we can divide evenly and we get 2, meaning we move up 2 and right 1. We have a slope of 2 here. The big key point here is to make sure that you always watch those negatives because it's easy to forget about them and you would get a completely different answer if you forgot. So make sure you always write it out and identify if you have any double negatives that need to turn into positives. The other way we can look at these that's not as efficient, but you can still do if you're having trouble using the slope formula, is by simply graphing the points. So here if we graph the point 3, 5 and 5, 10, we could look and on our graph count up 5, right 2, and get our slope of 5 over 2. Similarly, we could graph the point negative 4, 1, and 6, positive 21. And here again we could count on our graph and we would count up 20, right 10, and we would get our slope of positive 2. Now, it's not as efficient. it is a good way to check yourself if you're ever stuck and or confused. If you have any questions, bring them into class tomorrow and be ready to work with slope. Thanks, guys.